Alright guys, so now we're going to talk about distance, figuring out distance. This is going to be the last part of Lab 6, Absolute and Apparent Magnitude. You're going to have 3 questions that we're going to be doing this in. We also have a couple questions like this in your study guide, okay? And basically what you do is you work backwards. So in this case, we've already found out that our star has, let's say, star A has an apparent magnitude of +6, and our absolute magnitude is +1. Okay, now we need to figure out exactly how far away it is, right? Which means we need to work backwards. And it honestly starts off appearing very, very complicated. It looks really complicated, it sounds really complicated, it just seems scary, and it's really not as scary as it is. So the first thing you do is you subtract your apparent by your absolute. So you do +6 minus +1, right? So we get 5. That is our difference in magnitude. We start on this side, which means that we have 2.5 to the 5th, okay? Which means our difference in brightness is 100, okay? If we were going the other way, using our equation, okay, we would have squared something in order to get this. So we're going to square root it, which will give us 10. Okay, this is how we know we move 10 times closer. Reason being is because before, let's say we were X amount of parsecs away, we divided it by 10 because we were farther, and that gave us 10 times closer. Okay, and then we would square it to give us something on the difference in brightness, which gave us 100 times brighter. Okay, and that's why we square root what we get here. So we know we moved 10 times closer. So now we do, since we had to move it, we do 10 times 10. So we know that it was originally at 100 parsecs. Okay? Alright, well, let's try this again. Let's try it again. Star B has an apparent magnitude of +3 and an absolute magnitude of +1. Okay, again, m minus m, apparent minus absolute. 3 minus 1 gives us a difference of 2, okay? So that means our difference in magnitude is 2, which means we have 2.5 to the second, which means our difference in brightness is 6.25. Okay, now that we know our difference in brightness, we know that at this point we need to square root it because whatever it was that gave us this difference had to be squared. Okay, so we're going to take our calculators. We're going to go, okay, what is the square root of 6.25? Let's find out. Oh, look at that. It's 2.5. Okay, so that means we moved 2.5 times closer. Okay, so we're going to multiply it by 10. And that's going to give us 25. Okay, that means our star was at 25 parsecs. Okay? Simple. No matter what, you are going to be multiplying. Okay? We're not talking about anything that moves farther away in this instance. We're only talking about things that move closer. So we don't need to worry about the complication that is the other way, because again, you guys are not astronomers. Alright, so let's do another example. Star C has an apparent magnitude of +7 and an absolute magnitude of -3. Let's figure it out. Apparent minus absolute is going to give us 7 minus -3, which is going to give us 10. Ooh, interesting. What do we do here? Right? Well, this we have to split up. What and what is 10? 5 plus 5, right? So 2.5 to the 5th times 2.5 to the 5th, okay? Which means now we're going to get 100 times 100, which is going to be what? What's 100 times 100? 10,000. Good. Alright, so since we get here, and we know that in order to get to this point, because this is our difference in brightness, right? In order to do this, we need to square root it. Okay, so the square root of 10,000 is 100. So we knew we moved 100 times closer. Okay, again, multiply it by 10. 10 times 100 is 1,000 parsecs. And since it's greater than 10, we went 1,000 parsecs away. There we go. And that's how we find the distance of a star, using apparent and absolute magnitude. Alright, and let's try one more. One more, just to make sure that we all get this. Okay, so final star. This one we're going to call star F. Star F has an apparent magnitude of plus 8, and an apparent and an absolute magnitude of plus 3. Okay, again, m minus m is going to give us 8 minus 3. It's going to give us 5. Okay, oh, so simple. Difference in magnitude of 5, we're going to go 2.5 to the 5th, which means our difference in brightness is 100. Okay, again, square root it, because in order to get the difference in brightness, we had to multiply something. 100, square root of 100 is, let's see, what is the square root of 100? Well, let's be smart about it. Use the calculator. Square root of 100 is 10, okay? That means we move 10 times closer, okay? Again, we're going to do 10 times 10, which means our original distance was at 100 parsecs. Okay? Does that make sense to everybody? Use your calculator for this. Don't use just the off the top of your head, you're like, oh, 100 is 10. Best thing to do, always use a calculator, because on the exam, when you guys are doing this, guess what? You're going to panic. And it's okay to panic. That's what happens on exams. It's always easier to have a calculator with you so that you can do these things. Okay? Alright. And that is how you use apparent and absolute magnitude in order to find distance. Okay? Very simple, just working backwards, doing the same thing before as we did to find absolute magnitude, except now you're going the opposite way to find out where your star originally came from. Alrighty guys, and that's it for these 3 videos on how to do apparent magnitude, absolute, and finding distance. Good luck.